Okay, folks, this first joint, for joint A, you should have written the forces in the x direction equation, minus 500 plus AB. I find out by that AB equals 500. It comes out to positive 500. What does that mean? That means I've assumed the correct direction. It does act away. So that's 500. What about sum of forces in the y direction? You should have written plus 500 plus AC equals 0. What that tells me is AC is equal to a negative 500. What does the negative mean? Wrong way. So it doesn't act away, it acts back down. Okay? So I've solved for the two unknowns at joint A. Now I'm going to take these, I'm going to go back to my big picture, and I'm going to put in those answers. Okay? I've got AB being 500, and I'm going to switch the direction here for AC and say 500. Okay? Now I've got the answers at joint A. What I'm then going to do is I'm going to flip-flop these down to the other end of AB, to the other end of AB, and then this to the other end of AC. Notice that if it acts away from the joint, then at the other end it still acts away from the joint. If it acts in towards the joint, at the other end it still acts in towards the joint. Okay? Here's what the positive and the negative mean for me. If I always assume things acting away, and it happens that they are acting away from the joint, that means tension. If I assume acting away and it turns out negative, the negative means compression. So basically, AC is 500 compression and AB is 500 tension. Okay? So that's sort of what I do. I always assume an acting away. If it ends up acting away, that's tension. All right. Let's go to another joint. Okay? Let's go to joint B. Draw a free body of joint B. I got to put what I've got acting on it. I've got the reaction 500 acting up, and I also have this joint force which I just got through the flip-flop of member AB, and so I know it acts that way. I've also got this diagonal force that comes in from member BC. This diagonal BC happens to act at a 45-degree angle. How did I know that? Well, just look at the setup of the truss. 5 feet this way, 5 feet this way. Oh, I guess this diagonal, it has a 5 side and a 5 side, and I say inverse tangent of 5 over 5 gives me 45. How do you like this free body diagram? Well, it's okay. But the diagonal, usually I found in the past, what do I do with diagonal forces? I break them into their components. So instead of maybe looking at BC, now notice BC I drew acting away. I don't know if it acts that way, but I drew it acting away. How about I have BC cosine of 45, and I have BC sine 45. Okay? All right. Let me do sum of forces in the x direction. What do I have? I got this one. That's minus 500. I say minus because it's acting to the left. And then the BC x component is BC cosine 45. It's also shown acting to the left. And those are the only two x forces that I have. so equal to 0. I can bring negative BC cosine 45 on the other side. It becomes positive. Set that equal to negative 500. I can divide through by cosine 45. And what am I going to find here? I'm going to find out that BC is equal to a negative 707.1. Or we'll just round it to 707. Negative. What does the negative mean? Arrow the wrong way. I drew it acting out, but it really acts back in. And a negative also, based on what I just told you, means what?
It's compression.
Compression. So negative 707, that means it really acts the other way. I'll show it on my big picture coming back in. I flip-flop it, bring it to the other end of member BC, show it acting back in. Is there anything left for me to find? No. I got this member. I know that's 500 tension. I know BC is 707 compression. And I know AC is 500 compression. I found everything. But we can go ahead, and if you want, you can solve joint C, but this would simply be as a check. There's nothing unknown at joint C, but you can put all the forces on it because they should add up to be what? They should add up to be what? 0. So you can take a moment and check it and see if it does add up to be 0.